Bright Tuty. Every student matters.
Now let's start doing the exercise for this chapter. So we'll be taking questions from the topic physical properties of metals and non-metals. So the first question we have here is an in-text question which states, give an example of a metal which is liquid at room temperature. As we've already discussed, mercury is liquid at room temperature, and because of this property it is used in thermometers because it can rise and fall with an increase and decrease in temperature. So the answer here is mercury. Anything that can be cut easily with a knife. So the answer here is both sodium and potassium, but since for the sake of it we've written only one. Sodium and potassium are soft metals. They're really brittle. If you hammer them, they would break. If you cut them with a knife, they can easily be cut. So the answer is sodium. What is the best conductor of heat? Now we've already discussed this, that silver is the best conductor of heat. Although we don't use it to make wires very often because it's really costly, but silver remains by far the best conductor of heat in all the metals known. The next is a poor conductor of heat. Now the poorest conductor of heat is lead. We're not talking about elements here which do not conduct, we're talking only about which conducted poorly. So the answer is lead. The next question is, explain the meaning of malleable and ductile. Now I already explained this to you, that malleability means a substance that can be converted into sheets. So anything that can be hammered to form flat sheets is a malleable substance. And ductility means wires, so anything that can be converted into wires, that can be drawn into thin wires, is called as a ductile substance. So a substance which can be drawn into wires is said to be ductile. A substance which is said to be which can be beaten into sheets is called as malleable. Examples are copper, iron, silver, gold, and there are almost all metals show this property. You are given a hammer, a battery, a bulb, wires, and a switch. So these are all the apparatus that we have been given. How could you use them to distinguish between samples of metals and samples of non-metals? So we already know that the hammer would be used for physical properties of malleability and ductility, whereas all this together can be used to check conduction of electricity. We can create a circuit with these equipments and see if an element conducts electricity or not. Before we go further into the question, let's revise two concepts. The first, that metals are malleable and ductile. They can be beaten down into thin sheets. They will not break under that force. Second, they also conduct electricity. Almost all metals conduct electricity by the virtue of free electrons present in them. But non-metals, on the other hand, do not conduct electricity and are not malleable or ductile. So with this, let's start the first part of the question. The first test can be done using just a hammer. If a substance can be after being hammered gets converted into sheets, then it is a metal. If it is broken into pieces, then it is a non-metal. So anything that gets broken down into pieces on force like a hammer being applied would be a non-metal, and if not, then it would be a metal. For the second text, we'll have to set up an apparatus like this. We use clips, we use a battery, we have a bulb and a switch. We set up this entire structure, and in between the gap A and B here, we put in the element to be tested. So in between A and B, we put the metal or the non-metal that we have to test. If the bulb lights on, if the bulb goes on, it means that electricity is being conducted in this structure, and that means in this setup, and that would imply that the element that we have placed there is a metal. If the electricity is not being conducted and the bulb does not go on, that would mean that the element is non-metal, which is a non-conductor of electricity. So for the second test, we set up the arrangement using bulb, wires, batteries and switch to make a circuit. We then place the substance between point A and B. If the bulb starts glowing, then it is a metal, because metals are good conductor of electricity, and if not, then it is a non-metal. Now the second part says, assess the usefulness of these tests in distinguishing metals and non-metals. So how do you tell what is the utility of these two tests that we have devised? Now these tests do not work all the time, because we have studied that there are exceptions to the basic physical properties. Now although most metals are ductile and are malleable, Substances like sodium or like potassium are not malleable and ductile. If we hammer them, they would break. They are brittle, but that does not mean they are non-metal. So this test is not all-inclusive. In fact, graphite, which is a form of carbon, an allotrope of carbon, is a non-metal which conducts electricity. So there are certain elements that are exception to these rules, and that is why this test is not all-inclusive. So the exceptions we have are sodium metal, and we also have graphite. There are also other options, other elements which do not follow these simple rules, and that is why it is possible that we may not be able to judge accurately using this test.